Well, welcome. Welcome to Take a Ride on the Metro. How about that? So my name's Jeff Procyse. I'm going to be spending the next 75 minutes or so talking about this new thing called Metro. If you were in the previous presentation in this room from Brian, he focused on the design side of Metro. I'm going to be focusing on the development side, how you write code, what the Metro application model looks like, what you need to know as a developer if you're going to take a ride on the Metro, if you're going to jump on board this new platform. Before I get started with slides, let me mention a couple of things. I do have some slides I'm going to share with you, but I also have lots of demos I'm going to show you. Applications that are built to run on the preview version of Windows 8 that came out at the Build conference last September. Of course, it's public knowledge now that the next public version of Windows 8 comes out February the 29th. So very, very soon you'll be able to play with more bits. I'm going to give you, at the end of the presentation, a URL so that if you would like a copy of all the samples I'm showing you, you can go to that URL at your convenience and you can download those. So with that said, let's talk a little bit about Metro. So I did a lot of thinking about how I wanted to structure this presentation, knowing we only have 75 minutes together. And here's what I decided. There's certain key points that I want to get across. I don't know how closely you followed what's going on with Windows 8 and with Metro and all that, but I'm going to assume that you haven't done a lot of work with it. Maybe you haven't been following the story at all. So I want to make sure we all start on the same page. But more importantly, I want you to understand the significance of what is happening here. When you look back at our little industry, every 10 years or so, there's a sea change, isn't there? You know, we went from DOS to Windows. We went to COM, and then most of us made this big move to .NET. Well, in case you haven't realized this, there's another sea change coming, another fundamental shift in the technology. Now, I don't know about you, but as a developer, I like that. It gives me new toys to play with. Sure, there's a little bit of anxiety sometimes because we have new stuff to learn. But there is a sea change coming. My personal opinion, and I'm not a Microsoft employee, I'm just a contractor, my personal opinion is it's a good change. I look at what Microsoft is doing, and I like a whole lot of what I see. What I'm going to do is try to get across to you the key things that you need to know about this change that's coming so that you can decide whether you want to be on board with it, and my hope is that you will want to be on board. So what is Metro? It's part of Windows 8. As you may or may not know, when you write a Windows 8 application, there are two very different types of applications. There are the traditional types of window applications that still use the Win32 API and all that, and we now call those desktop applications. But in Windows 8, there's a whole another application programming model called Metro. Metro is a lot of things. It's a design philosophy. It is a shell for the operating system. It is an application model. If you choose to write a Metro application, writing it is going to be fundamentally different from what you've done when you've written Windows applications before. Now, the really cool thing is, if you are already a Silverlight developer or perhaps a WPF developer or have some experience with XAML and C#, you're going to feel right at home here because there is a XAML and C# and other languages model that we can use to write a Metro application. But it's also possible to write Metro applications using other platforms and other languages. For example, if you happen to prefer HTML and JavaScript, they are first-class citizens in this environment. Now, a lot of old Windows folks like me, when we first saw what was coming in Windows 8, we thought that was a little bit surprising, that HTML and JavaScript are first-class citizens. But when you think about it, it makes a lot of sense. There are literally millions of developers out there who write JavaScript code, many of whom have never seriously considered writing a Windows application before. The message that Microsoft is sending to those developers is you can now write Windows applications without learning new languages and new platforms. You can leverage the skills that you already have. So there are a lot of ways to go about writing a Metro application. At the end of the day, you choose the approach that you're most comfortable with. If you're more comfortable with XAML and C#, there's a way for you to write Metro apps. If you're more comfortable with HTML5 and JavaScript, there's a way to do that. You can even use DirectX and C, C++, Visual Basic if you're on the XAML side, and lots of other things. Now, I want to share with you a diagram you may have seen. This is a diagram that Microsoft first showed in September of last year at the Build conference in the US, showing the architecture of Windows 8. And there are a couple of really key takeaways from this diagram. One is we see this dichotomy, the two kinds of applications, the desktop applications and the Metro applications. There are also some things about this diagram that are kind of interesting and bear a little bit more explanation. One of the big things that you need to know about Metro, if you don't know already, is that there's a new API that you write to write a Metro application. That new API is given to us by the Windows runtime, better known as WinRT. So yes, there is some relearning to do. You will be writing to a new API, and you can see from this diagram that WinRT is what underlies all of these Metro applications. But I'll tell you that this diagram is just a little bit misleading. What you'll find when you start writing Metro applications is that you won't just be using WinRT. If you're using XAML and C# to write these apps, you're going to use a combination of WinRT and .NET, believe it or not. If you're using HTML and JavaScript, you'll use a combination of WinRT and the Microsoft Windows library for JavaScript, better known as WinJS. And just to give you a couple of examples here, one of the things that has always been a little bit bothersome about HTML is HTML doesn't have a control model. There's no way to declare a tree view or a list view or something and just have magic happen. Whereas in XAML, of course, we have a very rich selection of controls to choose from. One of the things that WinJS does is it makes up for that. It has a set of types implemented in JavaScript that you can use to convert otherwise ordinary HTML elements like divs into very, very rich controls. That's not really a WinRT thing. That is a WinJS thing. Another example, if you're writing a Metro application in XAML and C# and you want to do some networking, you want to make a call out to a REST service somewhere over HTTP. One of the first things you'll find is that there is no HTTP networking stack in WinRT. There is, however, in .NET. So, while it's absolutely true that WinRT is the foundation upon which we will build all the code that we write when we write a Metro application, you won't be using WinRT only. You will be using a combination of WinRT and WinJS if you're a JavaScript developer, or a combination of WinRT and good old .NET if you're a C# developer. Now, WinRT is one of the first things that you need to learn about when you come to understand the Metro programming model. I wish I could sugarcoat this and tell you if you know .NET, then there's no relearning to do. But in fact, there is some relearning to do. It's just something that we're going to have to put up with. It is a different API. And let me tell you a little bit about the motivation behind this. For years and years, the Windows API felt kind of old and decrepit to us. It was designed, 30 years ago? It was designed back in the days when C was the language of the day, before most of us even really knew what OOP was and things like that. The Windows team for a long time has wanted to fix that. They've wanted to build their own newer version of the Windows API. And that's how I look at this. This is the Windows API now. It's not the .NET API, which is technically separate from Windows. It is the Windows API, at least the one for Metro applications. Now, in a lot of ways, it feels like .NET. It's thousands and thousands of types divided up into namespaces. A lot of them have analogs over in .NET, but the APIs are very different. The namespaces are different. The class names are different. The method names are different. And there are things that are fundamentally different about the design of WinRT as well. One of the first things you'll find out about it, for example, is that it is heavily asynchronous. In fact, in WinRT, any method that you can call that could potentially take more than 50 milliseconds to return comes only in an asynchronous version. Now, I want to show you, before we start looking at code, I want to show you just a bit here about the kind of changes to expect. And we're going to start with a little bit of .NET and C# code. I pulled this out because it makes a good example to compare and contrast. Here's a little bit of code. that I've probably written 500 times in my life, and many of you probably have too, that creates a file in C# using the .NET framework, fires up a stream writer to write some text to that file, and then writes hello.net into it. In a Metro application, you won't create that file and write to it that way. Instead of using the .NET API, you will use the WinRT API. Here's what the equivalent code looks like using WinRT. Note, it's a little bit different. It's no more complicated, really, but it is a little bit different. And it is asynchronous. Notice, for example, that when I create that file, I do so asynchronously, create file async. There's not a synchronous method for doing that. Once I've created that file, if I want to open it and write to it, I call another asynchronous method to do that. Now, one of the things that's going to make your life easier as a developer is the new C# await keyword, which you see being used twice in this example right here. What does await do? It takes otherwise asynchronous code, or takes what is actually asynchronous code, and makes it feel synchronous. In other words, it simplifies the programming model. And yet, you have to be aware of what the compiler is doing under the hood. I'm going to show you some examples involving something called deferrals. And if this is new to you, if you haven't done a lot of async programming before, it is something you're going to have to wrap your mind around just a little bit. But once you do that, I think you'll find that it's a very good model. The cool thing about this API being so asynchronous is that it's really hard for you and I to write bad code. Not that you and I ever would. We write great code, right? But believe it or not, there are other people in this room that sometimes write bad code. And my definition of bad code is doing synchronous things on the UI thread. Don't you hate it when an application freezes up? It could be the person sitting right behind you that writes that kind of code, by the way. You can't, well, I won't say you can't write bad code. It's harder to write bad code with WinRT. How about that? Now, remember, WinRT is completely agnostic to language. If I'm a C# person and I feel comfortable with this, then this is the way I'm going to write Metro applications that use WinRT. But if I'm a JavaScript developer, I can do all the same things that C# developer can. In fact, I'm calling into the same WinRT API. It just looks a little bit different in JavaScript. Notice here, again, I'm calling that create file async method. Same method in WinRT that was being called from C# on the previous slide. But there is no await keyword in JavaScript like there is in C#. So in the second line here, you'll notice me calling a function named then. This is something you will see a lot in JavaScript apps that use WinRT. Then is a method exposed on an object called a promise. That object is implemented inside Win.js, that JavaScript helper library that helps you do things that WinRT doesn't. Basically, then is doing the same thing in JavaScript that the await keyword does in C#. It takes what is actually asynchronous code and makes it look synchronous. What's actually happening inside then is a callback function is being registered, and when that asynchronous I/O completes, then your callback function is called. Once more, there are times when we have to be very aware of what's actually going on under the hood so that we can make sure we don't trip up WinRT, and I'll say more about that in just a bit. So with that introduction, let me show you the first application, the first sample app that we're going to look at. So I don't need that one anymore. Let's flip back over here. The easy way to get to Visual Studio is to do a Control-D to go to the desktop. And this solution right here is the one that you can download at the end of this session here. There are actually several projects in it, some written in XAML and C#, some written in JavaScript and HTML. But I want to start with an application named Photo Finish. So we're going to get this thing up and running, and I'm actually going to use this in 2 or 3 of my demos to look inside these apps to see how they're leveraging WinRT.net and lots of other things. But let me take you on a quick tour of what the application does. So by the way, this device I'm running on is not a laptop. It is the tablets that were given out to build attendees back in September. It has a multi-touch screen. So I do have a mouse and a keyboard attached, but of course I don't have to have those. I'm going to use touch to drive this application here. Notice this Metro-ish UI, very simple. I think anybody could figure this out. If not, they probably shouldn't be using a computer. So I'm going to go out on a limb here and say maybe I should tap this screen. So I tap it. And what you see here is a WinRT file open picker. It's sort of the new file open dialog, if you will, but it's a lot more powerful and a lot richer, and it has that Metro look to it. It allows me, among other things, to go out on the internet and pull pictures in or go out to other places as well. What I'm going to do is select a picture of my daughter. This is an old picture. She is a freshman in college now, which if any of you have daughters at home, it makes you feel so old. But I want to expand this a bit here so you can see it. I'll show you how that logic for zooming works in a moment. And you can see she has some horrible red eyes in that picture. Now, I guarantee you that's not how she looks in real life. In fact, if she knew I was showing this picture, she would be very angry, I'm sure. So please don't tell her. But what I'm going to do is I'm going to fix those red eyes by touching them like that. Then I'm going to zoom it back down, and I'm going to pull up a Metro UI element called an application bar, and I'm going to click Save, and now you're seeing the new Metro file save picker, which allows me to save that file out to where I want to. I'm actually not going to save it at this point, so I'll just click Cancel. But that's the first sample that we're going to look at. Very simple design. Very easy to figure out. In fact, the only editing functions in there now are that red eye reduction thing, but ultimately I'll probably add other photo editing functions to this as well. Believe it or not, as simple as this application is, there's a whole lot we can learn from it. So let me pop back over into Visual Studio for a minute, stop debugging, and let me show you just a little bit about it. By the way, you'll notice in this project, or this solution, there are two projects, one named PhotoFinish and another named PhotoFinish.js. PhotoFinish, the one I'm showing you now, was written in XAML and C#. In fact, it was mostly ported over from what used to be a Silverlight application. But the one named PhotoFinish.js is the same application written in HTML5 and JavaScript. And one reason I wrote this application both ways is I wanted you to be able to compare and contrast if you're undecided about which way to go when you write these applications. So let's take a quick look here at this PhotoFinish app. Here's what I did to start it. In Visual Studio, when you create a new project now, you have several templates you can choose from for a Metro-style app. If you want to start with a JavaScript project, you select right here. If you want to select C#, you select right here instead. This is exactly what I did to start this application here. If you're a Silverlight developer, this project structure probably looks pretty familiar. Notice there's a main page.xaml there, just like you're used to in Silverlight. There's also a main page.xaml.cs. While the dialect of XAML here is not 100% identical to Silverlight, and after all, WPF wasn't either, there is a very, very high degree of fidelity. So porting a Silverlight application, the XAML part of it, is typically pretty easy. There are a few little things you have to do differently. Some of those things are just because we're running a very, very early pre-release product. The big changes, most of the effort involved in taking a Silverlight application over to Windows 8 and making it a Metro app is changing the C# code, because you'll be leveraging .NET a lot less and you'll be using that WinRT API instead. By the way, when you port an HTML5 and JavaScript app, which was originally designed to run probably in a browser, to Metro, the port is actually much easier. To a very, very large extent, you just take that HTML5 app as is, pour it into a Metro project, and it just works. What you'll typically find, though, is even though HTML5 is a pretty rich platform, there's certain things it can't really do yet, like give you a save as dialog. Once you've brought that HTML5 and JavaScript app into Metro, what you'll generally find yourself doing then is adding features to it, the things that you couldn't do in HTML5, but you can now do because you have access to the entire WinRT API. Let me show you really quickly here what the UI for this thing looks like. I'm opening up mainpage.xaml, and for the most part, what you see here is going to look like it might look if it were a Silverlight application. You'll see I've got a one-row, one-column grid, and I've got an image declared in it. I'm using that one-row, one-column grid to center up that image the same way I would over in Silverlight. In fact, you can see it right here, pretty simple UI. I'm using a composite transform. I'll show you why I'm doing that in a moment. That's actually how I'm letting the user drag the image around and scale it up and down and things like that. But again, a very high degree of fidelity with Silverlight. If you look over at mainpage.xaml.cs, I'm going to look at a little bit of this now. We'll come back and look at more of it later. You'll see some things that look familiar here, but also some things that are very different. For example, when I tapped that screen and you saw the file open picker pop up, here's the event handler that I had wired that to. And you're looking at code here that creates a WinRT file open picker, displays it for the user. There's nothing hard about this, nothing difficult, but it is different than the equivalent code in Silverlight. So when I ported this application over, this was one of the methods that I had to rewrite. You also see an event handler here for that for saving the edited image. You can see me newing up a WinRT file save picker. Again, just a different API. And if you look down through here, again, we're going to come back and look at more of this. You'll find that when it comes to actually manipulating the pixels in the image, and I've got a method called reduce red eye, I believe. Let's see, where did I put that? I guess I could give up and do a search for it. Remove red eye, here it is. But the really cool thing about this, in a Silverlight application, if you're going to do pixel editing like I'm doing here, you use the writable bitmap class to do that. Well, guess what? There's a writable bitmap class in Windows 8, technically in WinRT as well. So I just brought that exact same code over. Now, there are some differences in the API. Silverlight's writable bitmap, for example, has a property named pixels, which is an array type property that exposes all the pixels in the image in row first order. They changed the name of that property in Windows 8's writable bitmap, and they changed its type. It's now an iBuffer. So if you want to actually read or write pixels, you have to call another method to convert that abstract iBuffer into an actual readable, writable stream. Nothing hard, just some minor changes I had to make from the code as I brought it over from Silverlight. So this is what the project structure looks like if you choose to go the XAML and C# route. Let's look at the same application really quickly to see how its structure compares had I chosen HTML and JavaScript instead. So let's close this down. And let's see here. I'm going to make this other project, photofinish.js, temporarily the startup project. And I'm going to do an F5 to launch it. And you're going to see it's going to look almost exactly the same on the outside. I didn't put the message up saying tap a photo to, or tap the screen to open a photo. What I did do is this. That element you see at the top of the screen is just an ordinary HTML input type equals file element. When I brought it into this Metro app, we see how Metro renders that out. Without me doing anything, when I push or tap the browse button, because this is HTML5 code running in Metro, it automatically goes and creates and displays that file open picker for me. I didn't have to write that code. I can now go out and find a picture. Let's see if we can go find the same picture I had in the previous exercise. And I'll click it, and there's that photo again. I'll see if I can touch here and maybe fix those red eyes. Kind of missed it the first time. And I think I have an application bar in here. Oh, no, I put a save button up there. Again, when you bring an HTML5 app into Metro, one of the things you'll find is that you now have access to features and functions that you never had access to before. I wanted the user to be able to save the edited file, so I put the save button up there. All I'm doing is, in JavaScript, creating a file save picker and displaying it pretty much just like the C# code you saw a moment ago. Now, what does this project structure look like? I'll cancel that out. Let's go back to Visual Studio and do a stop debugging. So let's see. Let's go open that project up here in Solution Explorer. It begins with a page Visual Studio created for me named default.html. When you look through that, you'll see what my DOM looks like here. Not much different functionally from what you saw on the XAML side, just declared very differently, of course, because it's HTML. You can see my input type equals file control, my button control, and you can see that big HTML5 canvas declared in the middle that I use to display the selected photo to the user, to manipulate the pixels and things like that. Now, if you wonder, how was it that I fixed those red eyes in this app? There is no writable bitmap in HTML, right? But there is in HTML5 the Canvas API. So what I've done here is use the Canvas API. I had originally written this to run outside of Metro, to run in a browser. it required almost zero changes when I brought it into Metro. All the logic I had written to take an image, to wrap a canvas around it, technically to wrap an HTML5 image data object around it, to manipulate the pixels, to take the edited pixels and display them to the user by calling put image data and drawing them back out onto a canvas. All of that was developed outside of Metro, and it just worked when I brought it in. So, again, one of the big takeaways here is that whether you're coming in from Silverlight, whether you're coming in from HTML5 or whatever, there's something that ought to make you feel comfortable here. No matter which direction you're coming in from, though, you will be spending some time learning WinRT. One last thing I want to show you while we're in Visual Studio. Let's go over to the JS folder, because there's a little file there named default.js, which is the code behind, if you will, for default.html. When you look through here, you'll see me doing a few things when the application is started up, like creating the canvas. I'm actually creating two canvases, one declaratively, one programmatically, for reasons I won't go into. I actually have to have a hidden canvas to do the red eye reduction here. For example, here's the JavaScript handler for that save button. This code right here creates and displays a file save picker. All I did, I literally took that C# code from the other project, cut and pasted it over, and converted it into JavaScript. It wasn't that bad. So both of these apps use WinRT and use the features and functionality there. Does the user even know whether it was written in XAML and C# or HTML5 and JavaScript? No. They probably have no clue whatsoever, because again, both of these languages are first-class citizens in the Metro environment. Okay, are you with me so far? No one has gotten up and run out of the room screaming. I take that as a good sign. So, since you're still hanging in there with me, let's pop back over here and let's look at a couple more slides. No, don't let other people see content on my PC. What's that? Perhaps some indecent pictures of the Yeah. What's funny with when I come to a presentation like this, I take all the indecent pictures off before I come. Yeah. I was actually teaching a class at Microsoft once, and someone connected to my PC without my knowing it and put some interesting stuff on it for the class to see. And to this day, there are people at Microsoft that don't believe that that wasn't stuff I put on my PC. By the way, one of my friends on Facebook recently suggested something to me that sounds so fun, I'm going to have to try it sometime. He was very unhappy with his boss. This gentleman is a developer like me, so he put out a message on Facebook asking for advice from other developers on really bad things he could do to his boss. And what one person suggested was take a screenshot of your boss's desktop, make that his desktop background, and then delete all the icons from the desktop. Said it will absolutely drive them crazy. In fact, I'm scared now because someone may do it to me, but how ingenious is that, huh? I mean, you could cost someone hours of time. Yeah, I love it. Okay, now let's go on a bit here. The second thing I want you to know about Metro is how you take user input, specifically touch input. Now, Microsoft made a big deal at the Build conference last September of saying, not just once, but several times, Windows 8 is a touch-first operating system. Clearly, they want this to be an OS for tablets, but it's also an OS for desktop devices as well. And just because we say it's a touch-first operating system doesn't mean that it's that to the exclusion of everything else. In fact, I love the input model that they've built into Metro. If you look at Silverlight or Silverlight for Windows Phone or even WPF, and you take all your criticisms of their mouse events and their touch events and the whole model they use, they have basically addressed those and done everything right in Metro. I love this input API. Let me tell you a little bit about it, and then we're going to look at some code. So here's what Metro does in terms of touch input. Number one, it doesn't really talk about touch input. It lumps all input coming from the mouse, from styluses, or from fingers touching that screen into pointer input. And One of the things it does is it defines a series of pointer events, which you can register handlers for in JavaScript or in C#. If you're using XAML in C#, these events are fired from XAML UI elements, just like mouse events and some touch events are fired from XAML UI elements in Silverlight and WPF today. But notice you don't see any events that say finger down or mouse down. These are generic. That pointer pressed event fires whether that's a finger touching the screen, a mouse click, or a stylus, or something else touching the screen. Who knows? So this is the first level of processing touch input and other types of input into your application. Now here's a quick example. At the top in XAML, I've declared a rectangle, but I want to know when someone touches it, or they click it with a mouse, or if they're using a stylus when they touch it with a stylus, so I can change the rectangle's color. So I do the same thing I would have done in Silverlight or WPF. I wire up a handler right there in my XAML for pointer pressed events. Now again, that event is going to fire regardless of what it is that physically touches the rectangle. There may be times when you want to specifically filter out touch input or stylus input, and I'm showing how to do that here. If you want to know, yes, if it was specifically a mouse click that was used to press that rectangle, you can do it using this point by looking at the pointer device type property you see here. Now I put that in there mainly to show you that API-wise, yes, you can figure out what it was that actually touched the screen. In most cases, you won't care. All you'll want to know is, hey, somebody pressed that rectangle. But there's more. There are some higher level events that are built in. We call these the tap events, and they have names like tapped, double tapped, right tapped, and holding. There are similar events fired from Silverlight for Windows Phone if you've built applications for that. These work the same way, but these are not touch only. That tap event will fire whether the tap occurs with a finger, a stylus, or a mouse. Now you may wonder, how does a tap occur with a mouse? Officially, what tapped means is that the pointer device, whatever it is, goes down and then comes back up within a half second or so. So if you want to process simple gestures like this, it's all built right there into the runtime. You can leverage it from C# or from JavaScript. Quick example, taking that same rectangle you saw a couple of slides ago. This time, I want to change its color, but only when it's tapped. In other words, if that finger goes down and stays on the rectangle, that's not a tap. I'm going to ignore it. I want this kind of thing, like that. Did you notice that sound? It's not a very good tap, is it? Only when the user does that do I want to change the color of the rectangle. These tapped events make that very simple. But the really cool thing is there is some recognition right there in the system for multi-touch events. Now, if you've ever written multi-touch code for Silverlight or perhaps for WPF, you've probably dealt with manipulation events as well. Certainly, if you've built Windows Phone applications, you've probably dealt with these events. Windows 8 borrows that same model, but it fixes all the things that are broken, especially broken in Silverlight for Windows Phone. So bottom line is, if I want to allow the user to zoom in and out by using a two-fingered pinching gesture or something, it's almost trivial to do that. Whereas in Silverlight for Windows Phone, there's quite a lot of work I have to do to get it to work right. In fact, to really get it to work right, we often have to resort to the Silverlight for Windows Phone toolkit. In Windows 8, it works the way it was always supposed to. Here's something else cool about it. You get inertia built in. In Silverlight for Windows Phone, if you're letting the user scroll sideways with a finger through a bunch of pictures, for example, and you want that motion to continue when their finger leaves the screen, that's inertia, and you have to write the code to do that, typically using a XAML animation paired with animation easing to make the motion decelerate as it goes on. You get that absolutely for free in Windows 8. In fact, I'm going to demonstrate that for you. Let's go back over to that photo finish application, and I want to show you some code like this. This is all it takes to allow the user to take a UI element and move it around the screen with their finger, complete with inertia when they let go, if the finger's still moving, or to use the two-finger gestures to scale in and out. In fact, this is almost identical to the code that's inside Photo Finish. Let's go back and take a look at that real quickly. So let's get back to Visual Studio. and once more make the XAML and C# version of Photo Finish the startup project. And you've seen me do this already, but you'll see me do it again. I'll open that photo of my daughter, and I'll use a two-fingered motion to zoom in, two-fingered motion moving my fingers together to zoom out, and I can also take this and move it around. Now watch this. Inertia, I've got no code in here that explicitly adds inertia. I'm going to shrink that down a bit, send her flying off the side of the screen. Now I'm in a bit of a pickle, right? Yeah, how can I get back to it? Sometimes that inertia is not a good thing. So that's why I built in a double tap handler. Watch this, double tap, double tap, double tap. Ah, there we go. And everything resets. So there the picture is again right back in there. The code for making all that work was trivial. I don't want my boss to know that. I want him to think I labored over it for weeks. But the code was almost trivial. If you look here in mainpage.xaml.cs, let's close these two files down. Go back to the XAML and C# version and open mainpage.xaml.cs. You'll see a little bit further down here some event handlers. Let's go find them. Right here, photo tapped. I want to know here when one of those red eyes is tapped. And I specifically only want to fix that red eye if it is a tap, if the finger or other pointer device makes contact with the screen and rather quickly lifts off. So whereas in the old days I might have written a mouse down handler, or in jQuery or something a click handler, I just register a handler for the tapped events, firing from that XAML image, and boom, the system calls this event handler when a tap occurs. As far as the pinching motions go, this is literally all it takes right here, pretty much what I showed you in the slide. If you look back at the XAML, I declared a composite transform and attached it to the image. Composite transform allows me to scale, rotate, translate, and do other, well, scale, translate, and rotate. And all I'm doing with my event handlers is scaling those things up and down. The 4 lines you see near the bottom are only there because I wanted to constrain it. I didn't want the user to be able to zoom down past a scale factor of 1 or zoom out beyond a factor of 4. Otherwise, I could have made it even simpler by removing those 2 lines. Again, I didn't have to write anything to get inertia. I'm pretty much letting the system do everything for me there. That's a quick look at pointer input in this environment. Yes, Windows 8 is a touch-first operating system, but that doesn't, again, mean touch to the exclusion of everything else. In fact, every app that I've got here, every sample, I can just as easily drive with a mouse as I can drive with a finger. So, go back over. Actually, while we're in Visual Studio, let me show you one other thing. I'm going to run another one of these projects here. In fact, I'm going to run a couple of them. Let's make this one named Metro Life the startup project. And this is actually a port I did of a Silverlight for Windows Phone application that I wrote and published in the store. It's a free app you can go download for the phone. It's actually a lot cooler on a tablet. This one is a Windows 8 Metro rendition of the old Game of Life. John Conway back in, I think, 1970. Published in Scientific American magazine, this cellular automata game named Life. It's one of the most popular computer simulations ever. When I start learning a new platform, one of the first things I often do is write the Game of Life. So what you can do in here is take a finger, a mouse, or whatever, and you can draw patterns of cells like that. Each one of these things in this case is just a little XAML rectangle. And let's see here, it's kind of fun. Sometimes I'll just sit and do that for hours at a time. And then I'm going to bring up my application bar with a little swipe and tell it to start. And what it's going to do is start a simulation running using John Conway's genetic algorithms to compute from the current generation of cells what the next generation should look like. And it'll just keep going until the cells all die out or they reach a steady state or something like that. It took almost no work at all to port that over from the phone. I'm trying to hit pause there, because I already had the core logic in there, and all the core logic just worked. I made a few changes using Metro's application bar rather than a Windows Phone application bar and things, but again, wasn't much work involved since I already had a code base on Windows Phone to bring this thing over with. One more example I want to show you while we're here in Visual Studio, just for fun. If you were in my HTML5 talk yesterday, you saw an HTML5 version of this. Here's a XAML and C# version written for Metro. Let me make it the startup project. And let's see here. It is called Mandelbrot. It is a touch-supportive Mandelbrot fractal viewer. The entire UI of this application is just an image. In this case, the pixels are being generated with a writable bitmap. If it were HTML5, I'd be generating them with the Canvas API instead, but I can touch like that, and it will zoom me in so I can just kind of drill down into the Mandelbrot set and see more and more as I drill down and find things that are more interesting. So some very simple touch logic there, taking taps. Most of the logic is writable bitmap logic. And in the HTML5 samples that you can download if you want from yesterday's session, you could take the HTML5 version of this and probably in 15 minutes have it converting into a Metro app, because that HTML5 version is pretty much just going to work once you bring it into Metro. Okay? Are you still with me? I haven't left anyone behind. Do you like what you see here, out of curiosity? Is it interesting? It's a new model, isn't it? It's very different from what we've done before. In fact, I think in this next topic here, I'm going to try to shock you just a little bit. Not everything is good news. I want to be totally honest. Let's see here. I bet I can click right there. There we go. Oops. There we go. Okay. Let me tell you some of the bad news. And it's not really bad news, but it's something that may be a bit surprising to you if you haven't heard this before. The application lifecycle of a Metro app resembles that of a Windows Phone app much more than it resembles that of a traditional Windows application. Now, if you're a Windows Phone developer, you know exactly what I mean. On the Windows Phone, only one application can run at a time. When that application is not in the foreground, it is suspended. Generally, the process image remains in memory, but all the threads in it are suspended. One of the reasons that the Windows Phone team made that decision was knowing that Windows Phones were going to have these 1 gigahertz ARM processors in them. They were concerned that if a bunch of apps were all running at the same time and hogging the CPU, it would make the application in the foreground feel very slow, and they were afraid that that would doom the Windows Phone. What's interesting is Metro uses almost exactly the same model. Only one Metro application can run at a time. When the user has switched away from your Metro app and is running another one, yours is suspended. And if you go into Task Manager, you can actually see that it's suspended. Now, what does suspended mean? It means basically the same thing it means on a Windows Phone. It means that the process image probably remains in memory, but the threads are suspended. Now, as there is on the phone, there are mechanisms for doing background processing in Windows 8 Metro, but it is absolutely true that to first order, only one Metro application runs at a time. But here's the rub, and this won't surprise those of you that have done phone development. You know that on the Windows Phone, when an application is suspended, it may be terminated, right? In fact, on a Windows Phone, in Windows Phone 7.1 Mango, they made some very fundamental changes. Whereas in Windows Phone 7.0, you were virtually guaranteed to be terminated when you were suspended. In Mango, you're almost guaranteed not to. But if the memory manager decides it needs that memory for other things, it will terminate your application, remove the process image from memory, and guess what? If that happens and the user switches back to your app, they're probably not going to be very happy. In that photo finish application, they'll have lost all the editing that they've done. If it's a data entry application, if they swap back to it and it happened to have been terminated while it was suspended, they will have lost everything. Would you like that as a user? Of course not. That's why in a Metro app, one of the most important things that we have to do as developers is the same thing that Windows Phone developers do. We must assume that app can be terminated at any time, because indeed, at any time while it's running, a user can switch away from that Metro app to another one. And once it is switched away from, there is no guarantee ever that your process isn't going to be terminated. We need to create the illusion, if we are terminated and the user switches back to us, that we weren't terminated. That's why PLM, Program Lifecycle Management, is one of the most important things that you'll ever learn about as a Metro developer. Again, if you're already familiar with this on the phone, this is not a shock. It's not a big deal. It's extra work, yes, but it doesn't scare you. If you're a Windows developer or a .NET developer and have never run into this before, it can be a little bit shocking. But it is what it is. It's something you have to be aware of. Now, the actual model for application lifecycle, or PLM in Windows 8 Metro, is a little bit different than it is on the phone. Different set of events. Here's what you need to know to first order. To do proper PLM in a Metro app, after I tell you this, we'll bring up some code and we'll look to see how I did it in the Photo Finish app. Number one, just before an application is switched away from or suspended, an event named suspending fires. What you'll need to do in every Metro application you write is be very sure you register a handler for that event. That is your opportunity to save any state, any data that you're going to need to restore the state of that application if it is terminated while it's suspended. Also, if the app is reactivated, and there's never a guarantee that it is, maybe the user switches away and never switches back. If it is reactivated, a virtual method is called, and some information is passed via parameter to that virtual method telling you exactly what happened while your application wasn't running. It tells you, for example, whether your application was being launched for the first time, or whether it's being reactivated or relaunched, if you will, after being suspended. It also tells you if you were suspended and terminated, and that is your signal to spring into action and restore the state that you saved when that suspending event fired. Now, here's an example of how we process a suspending event. And one of the big questions to ask is, okay, where do we store that state so that where do we save it so we can possibly restore it later? In the Silverlight for Windows Phone, there are basically three places we can store it. There's page state, application state, and for really big objects that we need to serialize, there is isolated storage. It's very different in Metro, same conceptually, but different API-wise and different mechanically. In this example here, I'm staving the state of this very simple application, simply what the user's typed into a text box, out into something called local settings. Now, local settings is sort of a dictionary of key value pairs that's stored in the local file system. There's also, if you want to store more complex and more structured data, something called local data, which is kind of like a virtual folder in which you can create virtual files. But another interesting capability that Windows 8 brings to this is something called roaming settings and roaming storage. For a lot of us, when we log into a Windows 8 device, we're logging in with the Windows Live ID. And if instead of using local settings or local data, if in my app I save my state in roaming settings or the roaming folder, guess what? Windows 8 automatically synchronizes that across all the devices that I've logged in with that Live ID on out in the cloud. Now think about that. You can be working with the Metro application on your tablet. You can get to a certain state in it, and then you can shut down. Maybe it's the end of the day at the office. You shut down, you go home, you pull up that same application on Windows 8 on your desktop PC, and you pick up exactly where you left off when you were using the tablet at the office. That's what roaming storage is all about. Now, in this case, I'm just storing the data locally. Remember, if, after being suspended, if I'm terminated, I'll need to use that state to restore the state of my app. So what I do is over in app.xaml.cs in the XAML world, I override a method named onLaunched. In fact, Visual Studio overrides this method for you when you create this project. And what I do there is look at the parameter passed in to find out, was I suspended and terminated? If yes, then I'm going to reach back down into local settings where I saved my state, and I'm going to restore it from there. Again, this is something for which there's no way around. Now, the fact is, you can get away without doing this sometimes, because most of the time, your application's probably not going to be terminated while it's suspended. But again, you never have a guarantee that's going to be the case. You always must assume when you're suspended that you are going to be terminated, and you have to do what I showed you right there. I'll show you what it looks like in real life in a moment. Do want to mention one other thing with regard to application lifecycle or program lifecycle management, and that is another event named resuming. Every time your application is resumed after being suspended, whether it was terminated while it was suspended or not, the resuming event fires. Now, interestingly enough, when this event fires, it doesn't convey any information to you telling you what happened previously, whether you were terminated or not. So there's some confusion that I've seen in the dev community over why this event even exists. Here's the intent of the resuming event. If your application displays data that could become stale while you were suspended, you take this event and you use it to refresh the content, irrespective of whether you were terminated while you were suspended or not. Now, I've got an example of that to show you as well. In fact, let's go back to Visual Studio and take a look at a couple of more examples. Let's get back to VS here. Maybe I'll just go this way right here. Here we are. So first off, let's look at the PLM code in Photo Finish, since I have that one open right now. Now, let me run it again first, because let's talk about what does state mean? How do you save the state of the app? Well, I mean everything. Whoops, I've got the wrong start project there. Let's go back and shut that one down and make Photo Finish the start project again. So in this application, I don't use text box controls. If I did, I'd literally have to save what the user's typed into it. But there's several things I do have to save. For example, since I'm allowing the user to scale the image, I need to save the current scale factor so that if I'm suspended and terminated while this application is gone, I can restore it exactly the way it was. I also need to store the position of the photo since I'm using a composite transform to let the user move the thing around. If the user has edited that image any, I need to make very sure to save that edited bitmap each time I'm suspended, just in case while I'm suspended I'm terminated. I don't want the user to lose all those changes when they came back. So what you'll find when you look inside this code is that the PLM code is non-trivial. It's not difficult, but it's non-trivial, and this will be typical of Metro applications. Let's scale that back down just a bit and go back to Visual Studio so I can show you what I mean. And it looks like I've already stopped debugging there. So there are a couple of key things that are going on here with regard to PLM. Number one, up here near the top of mainpage.xaml.cs, when this thing started up, I registered a handler for those all-important suspending events. This is going to get called every time before I'm suspended. What I'm doing here is literally saving the current width and height of the bitmap, since the user can scale it up and down, the scale factors, the current position, even the state of the save button, which is disabled when the bitmap is unedited, but I light up, I enable it once the user makes an edit. I need to save that as well. So every little thing that has to be done to create the illusion that the application was never terminated at all has to appear right here. But the big one is storing the bitmap. What I'm doing in this code right here, notice I'm using local folder instead of local settings. This allows me to create virtual folders and virtual files inside it so I can store as much data as I want in any format that I want. And ultimately what I'm doing here is reaching in to the pixel buffer property of my writable bitmap, encapsulating all those pixels the user's editing, and I serialize it out to a virtual file in the local folder. Now, I told you earlier that there's certain things that will trip you up the first time you write this asynchronous code with await or then in JS. Let me show you something really important. If I were to comment out this line of code and this line of code, this application would be a train wreck. Nothing would be saved properly, at least nothing with this bitmap. Here's the deal. Notice these calls to await. Remember, the purpose of await is to take asynchronous code and simplify it, make it kind of feel to you like it's synchronous. But what's actually happening under the hood is that this function, this event handler, is actually returning. And then a callback function is being called. It's returning and it's being called again. The purpose of this call to get deferral, and this is something you'll use a lot in WinRT, is to tell the runtime, hey, I'm in this suspending event handler, and I've got some work to do, but it's asynchronous, so I'm going to be returning from this event handler. I want you to give me a deferral. So you bracket all this asynchronous code in an event handler with calls to get deferral and deferral complete, and then you're letting WinRT know when you're finished. Very simple once you know about it, but until you know about it, you can get some very strange behavior out of your code that uses a wait. So you'll see this and this a lot in WinRT. Let me show you one other example here, by the way. Let's go back. Actually, I was already in Visual Studio, so I didn't need to go back anywhere. Let me show you another application that I haven't showed you yet. It's called Weather. And it actually goes out on the internet and pulls some data down. This one, too, is written in XAML and C#, although I have built an HTML and JavaScript version. But this one lets us demonstrate the resuming event. Watch this. Let's run this thing. And it's going to give me a very simple Metro-ish UI that lets me type in a zip code, a U.S. postal code, like 12345. It's going to call out to a REST weather service using HTTP and find out that that zip code corresponds to the little town of Schenectady, New York, and that it's currently 35 Celsius there. Now, you know that's not Celsius, that's Fahrenheit, right? That would be very, very hot. And in New York, it's never that hot this time of year. I doubt Dubai is that hot in the summertime. I don't know. So if I suspend this app, if I do this, well, since I'm running in the debugger, it wasn't really suspended. Let's do this. I'm going to stop debugging, pop back out to the Metro desktop, and run this app from there. Now, which one is it? Is it that one? Yes. And let's see what it's like in Redmond, Washington right now. 35 degrees there as well. Now, it's not running in the debugger, so when I switch away from it, it really is going to be suspended. Let's go back here. Here's another Metro app running. In fact, if I were to do Control-Alt-Delete right now and bring up Task Manager, see suspended in the status column, you can see actually weather isn't suspended yet. One thing that Windows 8 does sometimes, it defers a bit before suspending in case the user switches back fairly quickly. But you can see Metro Life, which I haven't run in a couple minutes, is suspended. That's interesting. It just when it came unsuspended. That may be a bug in Task Manager, by the way. There are some bugs in there in these early preview bits, but the point is when I've switched away from it, it's suspended. Now, again, most of the time you can get away without all of this logic to save and restore state, but since you're never guaranteed you're not going to be terminated, you really need to put that logic in there. And I'll be the first to admit that logic can be non-trivial. There is a fair amount of work involved in a non-trivial app in doing it, just as there is in a lot of Windows Phone apps. Again, it is what it is, so it's something that you and I as developers have to be ready to do. That's why we're paid the big money after all. Let's go back here and go back to the slides because I've got more to share with you. Again, continuing with the theme of what are the most important things that you need to know about Metro to assess it and to hopefully get excited about it. Well, we've talked about lifecycle management, about suspending and terminating and resuming and all that. By the way, I didn't show you the code, but in that weather application, because it's entirely conceivable that if the user switches away from it, causing it to be suspended, let's say the user waits 30 minutes and then switches back, it's still going to be displaying that same temperature, which may be stale data by now. So in that application, and you can look at it for yourself when you download it, I do register a handler for resuming events. And each time the application is resumed, if there is current weather data shown, I simply fire off another call out on the internet to go refresh that data. That's what the resuming event is for. By the way, one other thing I'd like to tell you about that. If you're a Silverlight developer, you, like me, have probably been frustrated at times by the fact that by default you cannot go cross-domain or cross-origin with a Silverlight networking call, right? Same is true of Flash, same is true of browsers, even though XML HTTP request level 2 and HTML5 fixes that. On the Windows Phone, there are no such cross-domain or cross-origin restrictions. You'll be glad to know that there are none in Metro either. In that weather application, I'm using the .NET Framework's HTTP client stack to make the call out to this REST service. I'm using link to XML to parse all the XML that comes back. Pretty much, code just like code I would have written in .NET 100 times. Over on the JavaScript side, you can do all the same sorts of things. So, a good application to look at and to study if you want to see what makes a Metro application tick. But there's something else really important that I'd like to share with you about Metro apps as well, the concept of contracts. Now, let me see here. Let's go back over to a Metro app here. Well, in fact, I don't have to do it. I just took my finger and I swiped from the right side of the screen. There are keyboard shortcuts for all this as well if you're not running on a touch device, and sometimes mouse shortcuts too. That little thing that just appeared on the right is called the charms bar, and it's an important part of the Metro user interface. The idea is that we expose common functionality in our application in a common way in every app. For example, if I'm going to include a search feature in my app, I don't provide some button that says search. I implement something called a search contract so that if the user, while my app is running, or maybe even while it's not, pulls the charms bar out and clicks search, they will have a system-provided UI for doing the search. And that doesn't apply just to the app that's running. If there are other Metro apps installed on the machine that implement search contracts, they will appear as well so that they can be searched and activated if they're not even currently running. That's one type of contract, the search contract. Another type is the sharing contract. In a traditional Windows application, we often use the clipboard to share data. Sometimes we describe sharing as the Metro version of the clipboard. If I have data in my app, maybe it's a spreadsheet and I've selected a bunch of cells and I want to share it with other apps, what I can do is drag out the charms bar, click share, and then share that data out. Now to do that, I have to implement another type of contract called a sharing contract. It's fairly easy to implement. By implementing these contracts, I achieve a tighter level of integration with the Metro shell and hopefully make my application more appealing and easier to use for the user. There's even, by the way, integration for the settings charm down here. By default, the settings charm doesn't have, or the settings pane that appears when I select that charm doesn't have a lot in it. But it's possible in a Metro app to add additional commands or menu items that display customized panes. For example, if you want to build an about box into a Metro app, what you do is integrate with that settings charm, provide in JavaScript an HTML fragment, or in XAML, a little XAML page, defining the look and the content of that about page, and then by implementing a simple event handler, you have an about command show up in the settings pane. So contracts are important, and that's why I wanted to give you a quick look at what they are, how you write them, and show you how they're used in some of these sample apps that I'm showing you. So let's get that down there. I'm not going to cover all these contracts. I do want to pick one contract and show you how you implement it. We're going to pick the sharing contract because I think that's going to be the one that's probably implemented the most by developers. Again, sharing allows my application to share data with other apps using a clipboard type paradigm, but something that's much more Metro-centric. So if I want to be able to be a share source, that is, share data from my app, I implement a sharing contract, and that's pretty simple to do. What I do in my code is I register a handler for this event named data requested, which comes from an object called the data transfer manager. Bottom line is, if while my application is running, the user drags that charms bar out and clicks the share charm, I'll see this event fire in my application. And my job now is to take any data that I wish to share and to provide it to the OS. So if I want to share text, that's a very simple thing to do. I first provide a title and description, which can be consumed by a sharing target if they want, to display to the user some information about what they're receiving. But the really important thing is the call to set text you see at the end. Now, text is one of just many, many formats that you can put, that you can share this way, same way we used to share lots of different types of data through the Windows clipboard. But that one call to set text shares out a text string. Now, there are other set methods that we can use to share other types of data. If I wanted to share an image, for example, I might do something like this. Now, I'm assuming here that this is an image file that, whose contents we want to share, and that image file is named image.jpg, that it's in the user's documents folder. I'm going to show you it's a little bit more complicated if you're sharing out an image that's being edited like the one in my Photo Finish app, but you can still do it. And by the way, You can be a share source, meaning you provide data with sharing, or you can be a share target, which means implementing a slightly different contract. This is a quick look here at what it takes to be a share target. If you want to be the recipient of images that are shared through the sharing charm, you write code like this. But let me show you here in Photo Finish how we share the data and how much effort was involved in doing it. So let's pop back over to Visual Studio. And I know it's here somewhere. We'll find it this way. So I just stepped on my shoelace and untied my shoe. So let's first try to see if it works. I'm going to run Photo Finish again. Oh, I still had weather set as the active project, but I just remembered we already have Photo Finish running, right? In fact, we've already edited the images. You can see that I've already fixed those red eyes there. So I'm going to drag out the charms bar. I'm going to click Share, and here's what I do in this app. Yes, I am registering a handler for that data requested event. There's really only one thing that I could share from this app, and that is the image itself. So in my handler, I'm going to take this image, which is not a file, it's just a writable bitmap in memory. I'm going to serialize it out as a JPEG and offer it through sharing. So when we click Share, we'll see a list of the Metro applications that act as share targets in this app, and hopefully we'll see that image there. We were supposed to, but we did not. I should see a thumbnail version of it. This is actually a share target that comes from the SDK. I think the bug is there, not in my code, but I won't swear that to you. In fact, last time I ran this, I did see the thumbnail, so who knows? These are very early bits after all. So we'll get rid of that. But let me just show you real quickly. It is being shared. That share target just isn't showing it. I don't know why. But I did basically here what you saw in the slides. Let's go back to Photo Finish and mainpage.xaml.cs. And when the application starts up right here, you see me registering a handler for that data requested event. That means I want to be a share source. And in the handler itself, which we'll find just a little bit further down on share data requested, here's where I'm sharing the bitmap out. Now, I've written a helper method here named encode bitmap to stream. One thing that's really cool is sharing this image isn't as simple as sharing an image file out like the SDK samples do. This is actually a live image in memory that has perhaps been edited. Encode bitmap to stream takes advantage of image encoders built into WinRT. One of the things that I always wished were different about Silverlight was while Silverlight could decode a PNG or a JPEG, there were no image encoders built into Silverlight to take a writable bitmap and create a PNG, a BMP, a JPEG, or something like that. WinRT has all that stuff. About 15 or 20 lines of code, I can take any writable bitmap, I can encode it as a JPEG, a PNG, or whatever. If you're interested in seeing how it's done, you can see it by looking at my encode bitmap to stream method. And with that, 5 or 6 lines of code, and I am a share source in Windows 8 Metro. So, contracts, how you integrate with the shell. They make your Metro application a better application. Now, we have about 7 minutes left if my computations are correct. So let's move on just a bit. Here's another thing I'd like to share with you about a Metro app. Tiles are an important part of the Metro UI. It's not hard to figure that out. In the previous session, when Brian talked about Metro design, he probably talked about tiles. So you know already probably that when a Metro app is installed on a Windows 8 device, a primary tile is created for it. That way, if when the user wants to watch the app, they just go out to the Metro start screen, they tap that tile one time, and the app starts up. And I haven't shown how to do that, and I won't for lack of time, but of course you can customize what those tiles look like. In fact, tiles in Windows 8 Metro are much, much richer than tiles on the Windows Phone. On a Windows Phone, there's a limited amount that we can do with a tile. In Windows 8, there's a ton that we can do with a tile. In fact, I've got some examples in here showing some of the things that you can do with the tile. And I'm also going to talk about secondary tiles as well. In Windows 8 Metro, for example, you can update that tile. And there are a couple of different ways to go about it. While your application is running, you can execute code that takes your app's primary tile and changes content on the face of it. You could change imagery, change text, change account, which we call a badge, and change other things as well. You can also do it using the Windows push notification service. If you're familiar with tile notifications in Windows Phone, a very similar strategy is employed in Windows 8 Metro, whereby, let's say you're building an application that it's a weather app, and you want to be able to asynchronously send down notifications to a user if there's a bad storm approaching. What you could do is you can have a service running out in the cloud that's monitoring that real-time weather data. When it sees that an alert needs to be sent out, it fires off a call to the Windows push notification service, which in turn fires notifications out to all the Windows 8 devices that have been registered with a special URI that was passed up to your service. Very different in detail some, but very similar schematically to what we do in the Windows Phone, but with more options. Quick look here at how you locally update a tile in Windows 8 Metro. I'm using the WinRT Tile Update Manager class here to get a reference to my application's primary tile. Then I pass out some new XML describing what I want that to look like. You may know also that you can actually queue up notifications and let the operating system rotate the tile between. I said queue up notifications, queue up updates is what I should have said. You can let the operating system rotate every few seconds between the different content on that tile that you've specified. One of the really cool things about this environment is something that you need to know so that you can perhaps leverage it if you're writing Metro apps is secondary tiles. Every application has a primary tile. Again, it's created when the app is installed. But every application also has the option of creating one or more secondary tiles. Now, obviously, you don't want to be creating these just for the sake of creating them. The value of the secondary tile is that they can serve as a shortcut to your application, not only to start it up, but to start it in a known state as well. And I'm going to demonstrate this for you here in just a minute, but first let me show you how it works syntactically. If I wish to create a secondary tile, here's what the API looks like. It's pretty simple. I new up a secondary tile object. I pass some information about that tile into the constructor, including a string we called the arguments that will be passed into the application when the application is started, if it was started because the user pressed that tile. In other words, in a weather app, if I want to create a tile representing Redmond, Washington, and its zip code, if the user touches that tile, when my app is activated, when it's launched, I'll want to know what information was associated with that secondary tile, what zip code was associated with it, so I can immediately bring up the weather in Redmond, Washington in my app. That's the importance of these so-called activation arguments, and they can be anything that you want. Of course, you'll have to know how to get those arguments when your application is launched, and here's how you do that. Remember that onLaunched method in app.xaml.cs, which Visual Studio has already overridden for you? It's called every time your application is started up for whatever reason it was started up. Notice it's passed something called launch activated event args. Through the arguments property of that event args, I can find out if indeed I was activated from a secondary tile, and if so, what arguments I need to use, because the arguments passed in there are the arguments that were associated with that tile when the tile was created. You can also do updates on secondary tiles. You can do those updates locally or through push notifications, just like you can with a primary tile. But let me just show you here real quickly what secondary tiles look like. Whoops, let me go back. I meant to swipe the other way. Oh, we're dead. That's okay. I'll bring it back up because the last thing I want to leave you with is a URL of the code download. So I'll bring it back up. But first, let me show you this. Let's go back to this weather application here. And once more, let's get a zip code. I've done 98052. I'll do 98052 again. Actually, here's a really, really cold place in the U.S. Oops, that's too many characters. Let's get rid of one of those. That's a place up in Minnesota. It's like the frozen north in the U.S. I guess like Northern Europe. Boy, was it cold when I got here on Sunday. Wow. I'm so glad it's warmed up. I thought it was cold before I left back home. It's been cold, but wow, was it cold over here. Anyway, suppose I want to be able to quickly and easily find out what the weather is, the current temperature in young American Minnesota. Watch this. In the application bar here, I've added a command, a button that says Add Tile. I'm creating a new secondary tile here. The system pops up this little UI where I can enter information. I'm just going to select the defaults. And now if I go back out to my application start screen, I should find a new tile that says Young America, Minnesota. And when I click it, it's going to activate the application, pass in the zip code which I associated with the tile so the application can automatically go pull up the weather at that location. That's the value of secondary tiles. Again, they serve as shortcuts into your applications when that makes sense. And they're accompanied by activation arguments that, when activated, are passed to the application so it can determine exactly how it should respond when it's started up through that secondary tile. Now, let's go back here. I think we are out of time, which is perfect. Let me go back to PowerPoint here and see if I can figure out in Viewer. Oh, this is going to take a while. Is there a way in PowerPoint Viewer to get all the way to the end? How about if I do an end? Is there any? Yes, now I'll go back one. I promised you that if you want this code samples, I give them to you. Here's the URL right here. You can go download it at your convenience, and you'll have that same solution that I was using in these code samples right here. So, I think it's lunchtime. What do you say we have some lunch? Thanks so much for attending, and go out and build some great Metro apps, okay? Thanks.